Hi guys, just got these two questions we're going to do here. However, if you are looking at the PDF that I gave you guys of these questions, or you had printed it out, I changed the question a little bit. This is the first step that we would need to do, but I wanted you guys to focus on just figuring out all the different components of the forces, rather than answer the full question right now. We'll finish that up tomorrow. So you can still write this on your notes if you have that printed, because this will be the first step. We're going to calculate all the forces acting on the mop, as well as, in particular, the components, because we have an angled force here. Now, what we have in this picture is a mop. We have a force of 50 newtons acting down on it at an angle of 50 degrees. And they're saying that there is friction going on in between the ground and the mop. So let's draw a diagram, because we're trying to a free body diagram, because we're trying to draw all the forces. Now, even though we have this force coming down at an angle off over here, I'm not going to draw it that way. Whenever we have an angled force coming down, we want to draw it starting at the center, and then from the center, the direction of the force. So it's being pushed down, yeah? And then my angle is going to be coming off of here. That's because we always start all of our forces coming off of the center. Yeah. So if I have this angle up here, if I transfer this force down, that's what's happening. That's 50 newtons. And here's like my parallel line. 50 degrees is going to be on top now. So that's how we draw any forces acting down on an object. Transfer them to the bottom half of the object. So this is 50 newtons here. That's the applied force. Now we also have, because we know this, we have the force of gravity. We have the normal force. And then we have the force of friction. Now we're going to find all of these forces. Or at the very least, actually, I'm sorry, we're not going to find the force of friction. Sorry. In particular, we're going to find the force of the normal force, and then these components. We'll find the force of friction later. So let's look at this. To find the normal force, to start with, for example, this is all my y components. Because we're pushing down on the mop, the floor has to act upwards with a greater force because you're pushing down on it. So in order for the mop to not go through the floor, yeah, the floor has to act upward with greater force. So I have two y components. I have the force of gravity, and I have this applied force in the y direction. Again, because we're pushing downwards, we have a downward component of that force. So we can call this Fy, F applied y, if you want to do that. I just already wrote F of y. So we need to find these two things. Now we also, again, are going to have an x component to that applied force. So we'll address that in a bit. So let me move some stuff out of the way here. There we go. Okay, so we need to find the force of gravity and then this applied force, the y direction. So I'm going to go ahead and find the force of gravity real quickly, because that's not hard. Force normal is, go ahead and read the question, find the force of gravity acting on this mop. Force of gravity is just mass times gravity. So here's our mass. So you should have just done for the force of gravity 3.75 times 10, times 10. Plus, again, this force of y we're going to find in the y direction. So we have 37.5, the force of gravity, plus we're going to need to find this y component. So I'm going to pull my triangle off here. That's a pretty good triangle. We got 50 degrees. We got 50 newtons. I have my x component and my y component. Take a moment. We're going to go ahead and find both, but we're only going to use the y component here for right now. Go ahead and find the y component and the x component. Okay, let's check. So this is my opposite. This is my adjacent. That means in this case, my x component will be cosine 50 cosine 50. And my y component will be sine because it's opposite. 50 sine 50. So check this real quick. We've got 50, 50 cosine 50 is 32.1. And then we have 50 sine 50 is 38.3. So those are my x and y components. So my normal force, again, because I'm pushing down on the ground has to push back harder. And that's what the normal force is. How hard is the ground pushing back at you? 75.8. So that is, again, that's our normal force. We already found the x and y components, and we also found the force of gravity. So those are all the forces acting on it, minus the friction force. We're going to calculate that later. So you guys are going to try this one more time. Again, the important thing is that you know the normal force is adding the y components together, which is usually the force of gravity, and then any other y components that we have. So go ahead and try this one now. We have a force pushing down, so notice this is how they labeled it. We might be pushing from the top of the box, but that's the direction of the force. This is 35 newtons, and we have this is 30 degrees. I want you to try it exactly like we just did. Most importantly, you need to find the normal force, and go ahead and still find the x component as well of this force, even though we don't need it just yet. Okay, let's check. So my normal force is going to be all my y components, which is gravity, and this y component here. Yeah. Again, we're going to go ahead, we're going to find the x component. In order to find the normal force, we are going to have a force of friction, but we're going to find that later. I didn't give enough information for that. So normal force is all the y components. So we've got gravity, which is just, let's see, 3 times 10. 3 times 10, which is 30. I hope you're following along there. That was 3 times 10. Plus, I need the y component. So let's go ahead and find the y component here. I'm going to pull this triangle off. I got 30 degrees. I got 35. I need my y component. And my x component, I will be needing that for tomorrow's stuff. So we'll just make sure we find both. X is going to once again be cosine because it is the adjacent. Y is once again going to be sine because it's the opposite. So we've got 35 cosine 30. We get 30.3 newtons. And then 35 sine 30, we've got, for Pete's sake, what is that? 35 divided by 2. 17.5? Is that right? I'm having issues. Sorry, 1 second. There we go. Exit. Delete. 35 divided by 2. 17.5, I was correct, but my brain's not there, so I just wanted to make sure. Okay, so this is my y component. Again, I'm applying extra force to the ground, so the ground has to act up with greater force. So I'm going to add just my 17.5 here, and this is going to be our normal force, 47.5. So again, looking at our picture here, our force of gravity would be that 30. We would have over here, just so we can put it all together, a component of 17.5. My normal force is these two y components added together. And then I have my x component as well of 30.3. And then tomorrow, we're going to address the force of friction. So you have a little bit of an assignment. It's 4 questions. Most importantly, what you're doing in all 4 of them is calculating the normal force. All of the y components. Hopefully you can give it a shot. Let me know if you guys have any questions.